In this video, we are going to look at applications of exponential functions to solve for the independent variable. We have already looked at writing exponential equations to model situations, but then we use those equations to solve for the dependent variable. In this video, we are going to look at solving for the independent variable. So in this example, we are told that the population of 100 insects triples every 3 hours. Part A should look familiar. We are asked to write an exponential equation that models the situation. Before we begin to make the equation, we need to write the let statements. So we will let P represent the number of insects, and then we will let N represent the number of times the population triples. We don't simply let N represent the number of hours because we are told that the population triples every 3 hours. And finally, we will just remind ourselves that P is the dependent variable, so it will replace the Y in the equation, and N is the independent variable, so it will replace the X. So now we can make our equation. So the population is equal to the starting amount, which is 100, times the growth factor, which is it's tripling, so the growth factor is 3, which is 300%, and that is to the exponent n. So that is our equation. Previously, we used this equation and we were given n, and we would substitute in for n and find p. And now in part B, we are asked for how long it will take for the population to reach 10 million. So this time we're given the population value and we're asked to solve for n. We're going to look at two different ways. One way is called guess and check, and another way we are going to use logarithms. So we start off with substituting in for p, and we're trying to solve for this exponent n. We see that n is on the base 3, which is then being multiplied by 100. So we can simplify this equation a little bit by dividing both sides by 100. And we get 100,000 is equal to base 3 to the exponent n. So now we need to look at what exponent on base 3 will give us 100,000. So we are going to do guess and check until we get as close to the answer as we can. So we basically just pick a number, and I find students often pick a number that's far too large because they forget how quickly exponential functions actually grow. So we will substitute in, let's just say 20, because often that one gets picked in class. And that results in a really large number. So we are way off. So let's cut that in half to n equals 10. So we will now substitute in 10 for the exponent, and we get 59,049. So then from our two guesses, we can see that when n is 10, we are closer to 100,000. So I'm going to pick another number that's pretty close, and you could do n to the 12. And you can see that we are quite a bit above again. Now we are 531,441. So now I'm going to choose n is 11. And when you do that, you now get 177,147. So we're definitely getting closer. And you can see that our answer is somewhere in between when n is 10 and when n is 11. We're looking for 100,000. Let's aim to get a little bit closer by going to one decimal place. So now we will choose a value between 10 and 11. Let's just choose 10.5. So P equals base 3 to the 10.5. And you can see we're definitely getting closer to 100,000. But we said we want to one decimal place, so let's see if there's one even closer. So we're a bit above, so let's go to 10.4. We don't want to go too far because we're pretty close. And we get 91,635. So of those two answers that are the closest to 100,000, when n is 10.5, that is actually the closest. So we have found that n is 10.5. You likely won't be asked, but you could find this to more decimal places, so you would then guess and check between 10.4 and 10.5 and actually get pretty close to 100,000. But that's quite a bit of work. And most of you are probably already not liking this method, so I'm going to show you a more mathematical method using logarithms. But one thing to note, we are not actually done. Remember, n is the number of times the population triples, and the question asks how long. So how many hours will it take? So now we're going to have to take our n value and change that to the number of hours. So the number of hours is going to be the number of times that it triples, and then it takes 3 hours each time. So 10.5 times 3 is 31.5. So it will take 31.5 hours for the population to reach 10 million. So let's look at a more mathematical way of solving for this unknown, and that is using logarithms. Logarithms is a grade 12 expectation. I am not going to go into a lot of detail besides how to use this in this equation to solve for our exponents. In grade 12 advanced functions, you will go into a lot more detail about logarithms. You will learn what it is. You will learn about the rules of logarithms. You will graph logarithmic functions. But for now, we are just going to use it as a tool to solve for an exponent. So remember, before we started guessing and checking, we substituted in for the population and we divided by 100. And then we got 100,000 equals 3n. We have to do that before we use a logarithm. On the one side of your equation, you're only able to have your base with your exponent before you use your logarithm. So you have to divide it by 100. You don't want to use a logarithm here until you divide by 100. So now we divided by 100, we're good to go. So we are going to take the log of both sides. Log is just short for logarithm. So you're doing the same thing to both sides. There is a rule in logarithms that you can bring down the exponent of the base. So logarithms are a very useful tool to solve for exponents because it makes exponents become coefficients. So now that exponent n is now in front of the log 3. We are isolating for that n. So what we are going to do is divide both sides by log 3, just like you would when you're solving an equation. So what you get is log 100,000, I think I dropped a 0 there, divided by log 3, and that is equal to n. Now this you can do in your calculator, and you enter as log 100,000, the divide sign, log 3. And again, you get 10.5 is equal to n. For now, until you learn more about logarithms in grade 12, I don't expect you to show all of these steps. So I will highlight the steps I expect you to show. So the one where you've rearranged, so it's just the base of the exponent, and then where you divide. The log of the number by itself divided by log of the base, and that's equal to your exponent, and then of course your answer. So remember, this is again not the final answer, so just as we did before, we then have to say the number of hours is the value for n times 3. And that is how you solve for an unknown that is an exponent.